charged bodies as point charges if their sizes are very small as compared to the distance between them. All the charge content of the body is assumed to be concentrated at one point in space. Additivity of charge. Charge and mass are inherent properties of matter. So how do they differ from each other? Mass is always positive, whereas the charge can either be positive or negative. We can determine the total charge of the body simply by adding the charges as scalars or real numbers. Consider a system of three charges, Q1, Q2, and Q3. Then the total charge is given by capital Q is equal to Q1 plus Q2 plus Q3. Conservation of charge. We know when an atom loses an electron, the electron is transferred to another atom, thus making it negatively charged, and the losing atom as positively charged. The conservation of charge is a universal law. Even in high-energy interactions, a neutron decays and converts into a proton, releasing an electron. The proton and the electron thus created sum up to give resultant zero charge. Hence, the charge before and after the creation is equal. Hence, the charge is said to be conserved. Quantization of charge. All free charges are integral multiples of a basic unit of charge denoted by small e. Thus, the charge Q on a body is always given by Q is equal to N into E. Here, the value of a unit of charge is small e is equal to 1.602192 into 10 to the power minus 19 coulombs. The quantization of charge was first suggested by the experimental laws of electrolysis discovered by the English experimentalist Michael Faraday. In the International System of Units, that is the SI system, a unit of charge is called a coulomb. This is named after the French physicist Charles Augustin de Coulomb. It is denoted by the symbol capital C. There are about 6 into 10 to the power 18 electrons in a charge of -1 coulomb. Appear as a continuous charge distribution. This situation can be compared with the geometrical concepts of points and lines. A dotted line viewed from a distance appears continuous to us, but is actually not continuous in reality. As many points very close to each other normally give an impression of a continuous line, many small charges taken together appear as a continuous charge distribution. At a macroscopic level, quantization of charge can be ignored. But at a microscopic level, where the charges involved are in tens or hundreds, then the quantization of charge cannot be ignored.